Thanks everyone for joining us. We'll be starting in just a minute. We're going to let folks join the session here. All right, we're going to go ahead and get started. Thank you all for joining us. And hello, my name is Jen. I work with the OpenDDS team and the OpenDDS Foundation. We are pleased to have Dr. Justin Wilson. He is a principal software engineer at OCI here with us today. And today he is going to be talking to us about using OpenDDS's RtpsRelay and how that connects to IoT and IIoT applications. So we are going to be doing a live Q&A session at the end, and we'll answer as many questions as we can as time allows. If you would please put those questions in the Q&A application portion, and you'll see that at the bottom of the screen. If you are more than welcome to use the chat feature to ask us things. It will help us though if you put your questions in the Q&A so we can keep track of those. The chat is rolling, so it's easier for us to make sure that we get all of your questions answered. So I believe that is it as far as housekeeping things. So Justin, I will go ahead and, oh, you know what? Let me go ahead first though and cover a few upcoming events. We do have some online training classes coming up in October that we hope to see you all for. We have Introduction to OpenDDS Programming for Java and C++, building OpenDDS applications with DDS Security. And then the following week, we have OpenDDS Essentials and OpenDDS Essentials 2. You can always see upcoming classes and then view our entire course catalog for middleware, and we have the link dropped in there. So definitely check back often because we have classes that we will put on the schedule throughout the year. So we do look forward to you joining other webinars that we'll schedule, and then other training events that we'll put on, like I said, throughout the course of the year. So I think that is it for me now this time. So go ahead, Justin. Thank you so much.
All right, thanks, Jen. So we'll start with kind of the motivation for the RtpsRelay, why it exists. We'll then look at the design and how it operates, and then we'll get more into using it and configuring it, monitoring it, so on and so forth. And then finally, we'll look at a brief list of gotchas that can bite you if you're trying to use the RtpsRelay. So what's the motivation? So in a typical IoT scenario, there's a device that's typically a consumer grade device There's often a mobile application or perhaps a web application, but that device is connected to the user's home network, so it's behind some kind of consumer grade router. The mobile application is going to roam around, so it might be on Wi-Fi, it might be on cellular data, so on and so forth. And between these two entities is the internet. And what we would like to do is provide access, both control and monitoring to the mobile application so that the user can manipulate and monitor the device of interest, whether it be a thermostat or refrigerator or home security or what have you. The industrial scenario on the right is similar, except that the device is typically placed behind an enterprise router, as the device is probably in some kind of manufacturing scenario or something like that. The application may or may not be mobile anymore. Most likely it's probably more of a web application that's running in some kind of corporate intranet or running on the internet, perhaps in the cloud itself. So those are the scenarios that we're looking at, and we can kind of settle on the IoT scenario as representative of what we're trying to accomplish. So in terms of OpenDDS and DDS, we want our devices and applications to be DDS participants. We'd like to use the OpenDDS middleware to exchange data between our device and application. When we consider this, we'll just settle on the RtPS protocol for establishing connectivity. So RtPS stands for real-time publish subscribe. It's an OMG standard. It's a UDP protocol that gives us interoperability so that you can write applications using different DDS implementations. It gives us security, and it gives us XTypes, which allows flexible message definitions and forward and backwards compatibility. I won't necessarily get into a whole lot more detail of the RtPS. We'll look at a little bit more of it, but the main obstacle that we want to, or the main characteristic of RtPS rather, is how discovery works. So discovery works by using multicast to advertise an IP address that a peer can use to contact a participant. This is done in two phases. One is SPDP, simple participant discovery, and the other one is SEDP. SPDP always uses multicast to advertise an address, and every peer must then use that advertised IP address to contact that participant. So that leads us to some problems immediately. First, multicast doesn't work over the public internet. So there's no way for the device to send an SPDP message to the application using a multicast channel, because it's just not going to work. The second problem is that there's no stable public IP address to advertise. The IP address of the NAT firewall router on both sides can change. And especially given that the application part can be mobile, its public IP address might change during the session. So there's not a stable public IP address to advertise. And then finally, there's no direct connectivity. So even if the device could advertise its local address, it would just be advertising its local address, not the public address of the NAT firewall. Or it would be advertising its public address as seen by the internet. So we have a problem there in terms of there's a number of issues that would prevent RtPS discovery from working as is in the public internet. So to establish connectivity, we would like to introduce some kind of component that we'll call the RtpsRelay to connect these two DDS participants. So our problem statement is to create a horizontally scalable service called RtpsRelay that can forward RtPS messages between connected participants. And we'd like to expose this service on the internet to allow participants without direct connectivity to communicate. In this case, we can put them behind different firewalls and routers and so on and so forth, and they can get to this common endpoint, and that should allow them to exchange messages. And furthermore, we'd like to have no modifications to the RtPS protocol. So we don't want to introduce some kind of custom extension or something that would break interoperability in a strange way. So a slight refresher on RTPS. So first is that a list of partitions can be associated with a publisher or subscriber. Partition is just a string that defines kind of a logical subset of an application. And we're going to use partitions extensively in the relay for routing. SPDP stands for Simple Participant Discovery Protocol. And participants are identified by a unique 12-byte string called the GUID prefix. And all RTPS messages contain this 12-byte GUID prefix. SEDP stands for Simple Endpoint Discovery Protocol. An endpoint corresponds to a writer or publication or a reader/subscription. An endpoint is identified by the GUID prefix plus 4 bytes. We aren't necessarily interested in the endpoint identifier typically in this talk. RTPS messages can contain 0 or more info-dest submessages that contain the GUID prefix of the intended recipient. So this is important in the cases where one participant wants to send a message directly to another participant. The protocol encodes that information that the RTPS relay could potentially use to route messages between the different participants. So let's look at the design of the RTPS relay, and we'll first consider a single instance of the RTPS relay. So starting at the bottom actually is our client participant. This is the mobile app or the device. It sends RTPS messages to a component called the vertical handler. The vertical handler is actually replicated 3 different times, one for SPDP, another for SCDP, and then another for the actual data that the participant would be sending. The vertical participant can make a forwarding decision and send messages to the horizontal handler, and these are used to send messages to different instances. So we'll talk more about this in a subsequent slide when we look at horizontal scalability. The application participant is a DDS participant that is running in the client participant's domain. So what that means is it can discover the client participants and do discovery with them. And we're going to use this ability to learn something about the client participants so that we can form a routing table. After we do this discovery and discover their publications and subscriptions and their corresponding partitions, we can build a routing table that by sending that to what's a component called the relay participant. The relay participant is in a separate domain than the application participant, and it gossips routing table and other information to other RTPS relay instances. In terms of horizontal scaling, this is the way it's organized in the sense that the horizontal handlers from one instance are connected to the horizontal handlers from the other. They're sending UDP messages, much like the vertical handler, and they're replicated 3 times as well. And then we have our relay participant, which is gossiping information that's about RTPS relay instances and other things as well. We'll get to that when we look at configuration and monitoring. Some other topics that they're publishing. But that's the general organization, and we can continue to extend this, horizontally as much as we need to. And the RTPS relay instances form a mesh or a clique of peers, and that's what allows them to forward messages to one between client participants. So one of the things to keep in mind when using that is that the RTPS relay is an OpenDDS application. So it's first of all running the application participant, which again is a DDS participant in the same domain. It securely discovers readers and writers and the partitions. That is, if you're using security, which you should be if you're operating on the public internet. It's going to use this information to build a local routing table. So it knows that this client has an interest in this partition. And it's going to aggregate all of its partitions and send those to other relay participants. So if I'm interested in partition A, B, and C, all the other relay instances will know that I'm interested in A, B, and C, and any message relevant to A, B, and C will be sent to me. The relay participant, again, is another DDS participant, but it's in a completely different domain, and it's only used to talk to other RTPS relay instances. It does discover these instances using normal RTPS discovery, and then it starts sharing partitions that are interested. It also does other things like sharing status information and statistics, which we'll cover later. So how does this work? So the first thing that an application does when using the RTPS relay is it does discovery with the RTPS relay, and that goes through two phases, SPDP and SCDP. So the first thing that's going to happen is that the client participant sends its SPDP message to the vertical handler. The vertical handler is going to forward that message to the application participant. The application participant is going to respond with its SPDP message to the vertical handler. The vertical handler is going to then forward that message to the client participant, and then the client participant, at least the SPDP portion, is complete. So now the client participant knows about the application participant knows about the client participant. That leads to SCDP, where they start exchanging messages on the SCDP port. So again, the client participant is going to send an SCDP message to the vertical handler forwards the message to the application participant. The application participant sends its own SCDP messages to the vertical handler, and the vertical handler forwards to client participant. At this point, endpoint discovery is complete, and there's a number of SCDP endpoints, publishers, subscribers, liveliness, etc. The application participant is really only interested in the publishers and subscribers and the participant as well. At this point, the RTPS relay has all the information it needs. It knows the partitions, it knows GUIDs and everything, so that it can start forwarding messages between client participants. So I've talked a little bit about routing tables, but what are they really? So the application participant is reading the built-in topics to record partitions that are associated with each publication and subscription. So it maps this in two ways. Both a forward map from GUID prefix to partition. So whenever it receives a message from a client participant, it knows what partitions are relevant. And then there's also one that does partition to GUID prefix. So if it receives a message from another RTPS relay instance, it can, with the partitions on it, it can know what GUID prefix locally it needs to forward to. So the complete list of partitions is published to other instances via the relay participant, and each instance then builds a lookup table of partitioned other instances. So when it gets a message and it knows the partitions, it can look up all the other relay instances that are interested in that and forward it on using the horizontal handlers. So now that we've completed discovery with the application participant, the client participants start operating normally and interacting with others. So a client participant sends a message to the vertical handler. The vertical handler looks up partitions for the sending client participant, extracts any destination GUIDs that are present, looks up interesting instances using the partitions that it extracted. It then is going to prefix the RTPS message with routing information, such as the partitions and the destination GUIDs, and then it's going to send that to the horizontal handler of interested instances. The horizontal handler takes that prefixed message, strips off the partitions and any destination GUIDs, and uses those to forward to any local participant, any local client that is either in one of those partitions or has one of those destination GUIDs. So in keeping in mind just some things to consider in the operation is that if a client participant sends an undirected SPDP message or SCDP message, that is one without an infodest submessage, it's going to be forwarded to the application participant because it's one of the participants on that in that domain, and it's also going to be forwarded to everyone else in that group of partitions. There's an optimization to avoid sending to its own horizontal handler. So basically, if the destination is connected to the same instance, it can forward it directly. It doesn't need to go through the entire process. And finally, the most recent SPDP message for a client participant is cached and replayed when a new client participant is discovered in a shared partition. So what this does is it accelerates discovery by allowing that client to receive the SPDP message quicker instead of waiting on like a broadcast from one of the client participants. However, this feature it doesn't work robustly all the time, and we'll remove it in a future release, at which point the client participant will just resend its SPDP messages whenever it connects to a relay instance. Another feature, I guess you could say, is that the client participants periodically do connectivity checks with the RTPS relay. So the relay maintains a lookup table of client participants and how their public IP and port, essentially, that they're using. And it'll keep 3 of them, one for SPDP, one for SEDP, and another one for the data. As the clients are sending, if they don't periodically send information, then the NAT that they're behind will close that port to prevent incoming traffic that is unintended from reaching an application. So in order to keep the ability of the relay to send information down to a client participant, we need that client participant to periodically send to the relay. That's what happens, and those connectivity checks are done using stun binding requests and stun binding indications. I won't go into the details of that here, but it's a simple UDP protocol that has a request response mode and also an indication mode, which just is used for keeping these port bindings, is what they're called, alive. And the link to the IETF specification for it is there for you to use. So the RTPS relay, as you might imagine, comes with a lot of configuration options. I'm not necessarily going to go into a whole lot of detail here, but I do want to hit some of the high points. The first is that each one has an ID. This ID is used as a key in many of the topics that the relay participant publishes, so that you can identify which relay instance it is, and also to keep them unique. The horizontal address and the vertical address block can be where you start, can be specified, obviously. You can configure the domain that the relay is in compared to the application. You can also give the application participants some user data, and that's very useful when your client participant is that you can, as you do discovery, you can actually see any information that is associated with that RTPS relay instance. At a minimum, you can make it to where you can identify the RTPS relay and say, yes, I've completed discovery with it. There's buffer size configurations for how the UDP socket should work. Lifespan is how long it's going to keep around those client participant IP port records. So again, you can't necessarily keep those around forever, so those have to expire after a certain amount of inactivity. Similarly, there's an inactive period, which is typically shorter than your lifespan, where you can use to set a smaller period just to see if the client participant has its network connectivity is disrupted. Finally, there's a flag that says you can allow empty partitions. Allowing an empty partition is dangerous because a message sent in the empty partition will get forwarded to every single participant. That may be what you want, that may not be what you want, depending on how you structure your application. Security-wise, it takes all of the security parameters that are necessary, namely the six files, the identity CA's certificate, the permission CA certificate, the identity certificate and key of the application participant, the governance file that is shared, and the permissions file. The permissions file doesn't have to have anything in it, really. It just needs to have a valid permissions file because the application participant doesn't create any topics and it doesn't create any readers or writers. Also, if you're using security, you can use a feature called restart detection. So if you have a client participant that's in some kind of restarting loop or crash loop or something like that, you can detect that that's happening, and that cleans up the records in the RtPS relay, which makes the memory performance a little bit better. And the way that works is you can use a hash of the subject name in the certificate that appears in the GUID. So you can use that hash to detect that the application has restarted, and therefore you can take a corrective action. There's other options. So you configure logging. So if you want to see warnings, you can log discovery messages. So as messages come in from the built-in topics in the application's participant, you can log those. You can also log messages that concern the IP port mappings for clients, and both of those are certainly helpful when you're debugging a system using the RtPS relay. And then the relay is collecting statistics. So it collects statistics on the relay as a whole, or the relay instance as a whole, rather. It collects statistics on specific handlers to see how they're performing. And it also can collect statistics on individual clients. And you have the option to log these as they're happening, and also you can publish them on topics created by the relay participant, which means you can create an application that interacts with the RtPS relay to gather these statistics, and you can do whatever business logic you'd like to with those. So the logging is, again, there's a lot of logging that the relay does. I just wanted to take you through a few examples so that as you see things, you kind of understand what's going on. So as you log discovery, you'll see messages that come in from the bits, and the general format is that you'll have the GUID of the participant that was discovered, or the publication, or whatever it is. And then you'll have the actual data sample from the built-in topic printed in JSON format. In this particular case, we see this value is the GUID prefix, is the actual GUID. In this particular case, we can see that there was user data, and these are byte strings, so they're encoded all as numbers, which isn't the most convenient thing, but it is workable. And then you see a timestamp as to when discovery happened into the session. So from the time that this participant sent the first message, it was discovered in 0.005 seconds, 5 milliseconds. So that's an example of discovery logging, and there's similar ones for when a publication or subscription is discovered. The bottom set of messages relates to the IP port mappings. So the first message is essentially an announcement that this participant has sent a message to the RtPS relay, and this is the very first one. The second message says that this came from the SCDP port, and then it also gives you the binding. So in this particular case, I was running the RtPS relay smoke test, and the remote address was 127.0.0.1.501.26. You then have the idea of admission, and I'll talk a little bit more about admission control in a moment. But essentially, the client gets admitted, and then we see the SPDP port appear as well, and so on and so forth. So you would see a data one as well. So you can see, you can kind of get the story for how a client participant connects and how long certain operations take with respect to discovery. For statistics, again, there's a lot of information here. I don't necessarily want to cover all of it, but you do see this relay statistics as a logged JSON object, and you can see the ID given to the relay. You can see how many messages came in the time interval, how many messages left, how many bytes came in, how many bytes came out, how many participants are connected, how many new participants came, how many participants were expired, and so on and so forth. Similarly, for participants, you see a JSON message, and you see kind of the total number of messages sent to them, total number of bytes sent to them, so on and so forth. So there's a lot of information there. So RtpsRelay also has configuration related to monitoring. The first one is you can log thread status. So there is thread monitoring implemented in the RtpsRelay. So if you turn this option on, it will log out the thread status as it checks the thread status. And the thread status essentially contains the name of a thread and the utilization. The thread status safety factor is there to restart. It'll essentially abort the application if you enable thread monitoring and a thread has not checked in for this many reporting intervals. So if you are concerned about the RtpsRelay locking up, then you can use this to restart it, which is useful. There's also a utilization limit. So if you have the thread monitoring enabled, you can also set a utilization limit, which will cause the RtpsRelay to ignore client participants until the utilization comes below a certain threshold, which is the utilization limit. That's important for situations where you're restarting under load. So if you have a bunch of client participants that are out there configured to use a RtpsRelay instance and you decide to restart that RtpsRelay instance, it's going to try to do discovery with potentially hundreds or thousands of client participants almost immediately. So by using this utilization limit, you can prevent starting some discoveries until some other ones are complete. And you can essentially shorten the amount of time to complete those discoveries by limiting them using this utilization limit. So that's a very useful feature for production deployments. The feature publishing relay status liveliness is it uses the liveliness quas on the relay status. And this just sets the amount of time that is used in that liveliness clause. The option after that, which is publish relay status, publishes a status indicating whether it's accepting or not. And you can use that, again, for whatever purpose you want. We found it useful for building a load balancer in front that allows, essentially, if this relay is so busy and overwhelmed, new client participants can be directed to a different one. So again, here's an example of if you want to log the thread status, the first part, the thread ID is, again, the name of a thread. In this case, it was the main thread in the RtpsRelay, and you can see what its kind of an approximate utilization was in terms of percentage of its or fraction of a CPU. And then you can see the rest is just a DDS sample info that tells you that this instance is alive. So all throughout this presentation, I've talked about this relay participant publishing various topics. So on this slide, I'm really just want to go through what is available. And in some sense, if you want to write an application that interacts with an RtpsRelay, these are the things that are available to you. So first is a relay partition. So the relay partitions is a topic that is used for the RtpsRelay instance to say, I have clients that are in these partitions. Relay addresses is a topic where the relay can say, these are where my horizontal handlers are located. So that allows other relay instances to know where to forward the horizontal messages to. Relay status indicates if it's admitting new client participants. So again, that's pretty much, if you don't have the utilization and the threshold set, that's always going to be true. If you do set those, then the relay status will become dynamic and it'll indicate if it is admitting. Relay participant status is a topic that publishes 2 bits and the user data for a client participant. So the alive is based on that lifespan configuration value. So it'll be true if messages are coming in. When messages stop coming in, alive will go to false. Active is similar, except it's used on the inactive threshold. And then finally, you get the user data for client participants. So this can be very useful if you would like to see what client participants are out there that the RtPS Relay has discovered. You can build an application that subscribes to this topic. You can render that out, and then you can use that for whatever business purposes. Again, that's been a very useful feature in some of the deployments we've done of the RtPS Relay. There's the SPDP replay topic, which is effectively when a new client participant is discovered, sends a replay request that says, if you're in this partition, please send me the SPDP messages for that you have that are relevant to that partition. And again, that speeds up discovery. But again, that's going to go away in a future release at some point. You then have the participant statistics, which are, again, the messaging statistics for particular participants, and then similarly for the handler and the relay as well. So moving on to kind of configuring it, the RtPS Relay itself is configured like any other DDS application. Typically, you're going to use an INI file, or rather, you kind of have to use an INI file to configure it. And there's two domains you have to configure. You have to configure the application domain, and you have to configure the relay domain. In this particular config file, we've enabled the thread status monitoring because we'd like to do admission control. Our domain 1 is for the relay participant, so we have set up various discovery options that work. Some of the discovery options here, such as check source IP, are necessary for cloud. If you want to deploy it in the cloud, similarly, multicast doesn't work, so you need to disable that. And also, you need to typically set a max message size because the cloud may not support large frames. And similarly, the transport config is essentially saying very similar things. For the application participant, it's in domain 0. It similarly is disabling a source IP check, disabling multicast because we know it's not going to work. But we then configure the vertical handlers. So in this particular case, we're always going to talk to our local vertical handler. We're going to set a flag called RtPS Relay only because all of the traffic we send should go through the relay. And then we configure various things about message sizes and how often we want to resend our SPDP. Resending SPDP from the application participant is interesting. So typically a participant has a periodic timer where it resends its SPDP message. In a RtPS Relay instance, it could be associated with thousands or tens of thousands of client participants. And it doesn't really make sense to periodically send 10,000 messages out. So the RtPS Relay participant, or the application participant, sorry, is going to typically be configured with undirected SPDP 0, meaning it's always going to send a directed SPDP message. And we're going to make that periodic. So instead of sending them all on some interval, we take that interval and we split it up and we send a few throughout time so that periodically we get to everybody, but we don't necessarily do them all at once. And then the final configuration parameters here are tuning the way SCDP works and buffer sizes and so on. So to use the RtPS Relay, and this is if you're a client participant, how are you going to configure it? So first, in the RtPS Relay or the RtPS discovery sections in a config file, you have SPDP RtPS Relay address and SCDP RtPS Relay address. So those configure that I would like to send discovery messages to the relay in addition so that I can use it. In the transport side, for the RtPS UDP transport, there's data RtPS relay address, which sets the third data port. There are corresponding settings available via the RtPS discovery API if you're not using a config file and would like to do that, and the RtPS UDP transport API. These can be changed at any time. So that is useful from a load balancing perspective. So if a client participant figures out that it is not connected to an RtPS relay, it can find a different instance and then dynamically change these, and then it can start using a different RtPS relay instance. There are some custom built-in topics that are related to the RtPS relay. The first is the participant location topic. And this has a list of remote participants, and it has some flags indicating how they're reachable. Two of those flags are dedicated to the RtPS relay, one for IPv4 and one for IPv6. And this indicates that the local participant has received messages from the relay that appeared to be from this that remote participant. So that gives you some idea that you may be talking to them through the relay, or at least talking to them through the relay as possible. If they're instead a local one, that is, you've received a message from them using a local address, it will attempt to optimize that and send it directly locally instead of using the relay, as it would just be more efficient that way. The other custom built-in topic is called the connection record topic. And this contains, this is kind of a generalization of the participant location topic. It's not necessarily a complete replacement yet, though eventually it will be. But the idea here is that there are certain connection records that we can, that you can use to monitor connections. So in this particular case, the type is, the protocol rather, is RtPS relay stun. So as we're doing connectivity checks with the RtPS relay, we can publish that information in this connection record topic. So you would see both the SPDP, in this particular case is port 4444, which is to the left of the protocol. You would see also one for the CDP, as it's doing these connectivity checks and publishing these connectivity records, or connection records. There's also reported latency, so you can measure the latency, the round trip latency that a stun connectivity check is taking. So that in this particular case, that was 1.3 milliseconds. So again, this is running locally and it's very fast. Realistically, that's going to be more, but that allows a client participant to measure its connectivity to the RtPS relay. So there's some things to keep in mind if you're using the RtPS relay or designing an application with it. First, you have to keep partitions in mind. So the partitions are used by the RtPS relay to do efficient message routing. If you don't use partitions, it's basically degrading into multicast, and the performance is going to suffer consequently. That may not be important if an application is small enough, but as it scales out, it becomes important. Another problem you're going to face is bootstrapping the relay participants. So cloud environments are notorious for not supporting multicast, and since those are RtPS, those are using RtPS discovery, you have to figure out a way of getting around that. And typically that involves something that's going to emulate multicast. And there is a tool called the multicast repeater that we wrote for doing this, and there's references to that later. Use DDS security with restart detection is definitely recommended. Using the thread monitoring with admission control is definitely recommended because you're going to restart under load. You need to be aware that firewalls block UDP messages, so monitoring connection records and using the RtPS relay logging can diagnose problems with this. Firewalls close ports periodically after they're not used, so you need to ensure that stun connectivity checks are frequent enough to keep those ports open. And another thing to consider is that IP fragmentation is not globally supported. So as IP fragmentation happens, it's often the case that the first fragment might get through, whereas the subsequent fragments may not. So this means that you need to configure fragmentation at the RTPS level so that IP fragmentation doesn't occur. So this means setting a conservative enough threshold to force RTPS to fragment the message so that IP fragmentation won't happen and your messages won't get dropped. So with that, I'll open it up to questions now. Again, the RtPS relay is a horizontally scalable service that allows you to connect DDS participants across the internet. It's based on partitions, although you don't necessarily have to use them, but it is recommended. So with that, I'll take questions.
Thanks, Justin. I'm looking here at the Q&A and I don't see any now, but we'll give everyone a chance to digest all of that and put some questions up here in the Q&A while you take a drink there and a little break. We will hang around here for another minute or so if anyone has to go. We do thank you for your time this morning, for joining us. And like I said before, do keep a lookout for any upcoming events we do have scheduled, and check back with us often for webinars and training coming up. And he's advanced here so you can see some interesting articles that we have as references. And yeah, so please feel free to throw up some questions. Justin will be around here to answer those. And if you do have to go, thanks again for your time.
Slide 29 shows that the clients need to be configured with address of a relay. Assuming there's more than one relay instantiating, how should they determine the address of one to connect to? So that is a great question. So the first reference here, this designing a secure cloud-enabled peer-to-peer IoT application, has a high-level architecture for dealing with that. And what the architecture that we've seen work is to co-locate an HTTP server with each RtPS relay instance. Then load balancing can happen through the HTTP interface. So essentially, when a client participant starts, it can make an HTTP request. That HTTP request be load balanced to find an RtPS relay instance that would return the configuration that is necessary, and then the client participant would use that configuration. You can do a lot of neat things with that. You can connect our relay status topic to that, which would make the load balancer avoid RtPS relay instances that are overloaded and so on and so forth. To that end, a feature that we just added, and I mean just added, is the ability to host that HTTP server in the RtPS relay instance itself. We call that the meta discovery server. That effectively gives you a way to advertise kind of whatever you want to a client, and that is also hooked into the status, that admitting status, so that if it is overloaded, it'll return an appropriate HTTP status to make the load balancer avoid it. So the instance side support is there, and I'll probably write an article on it very shortly. The piece that's not quite there yet is the client side support, and that's somewhat of a client specific or an application specific issue, but we are adding support on the server side for it. The slideshow logging example seemed to be using a JSON format. Why was that format selected? What are the best practices for using JSON with OpenDDS? Another good question. So the JSON was really selected based on the ability of a lot of log analytics tools to process JSON. So by encoding portions, at least of logging messages, those can be automatically parsed and searchable, which is a very useful feature when you're trying to debug or monitor something. So that's why JSON was selected. OpenDDS does come with support for that. So if you enable the rapid JSON support, you can basically serialize any IDL defined type or a core type, so, struct and things like that, structs and the primitives to JSON, and that's what the RtpsRelay is doing. It's taking the data types that are defined by the built-in topics and serializing them in that way and logging them out. So in terms of best practices, I don't necessarily have a lot of them, other than if you want something logged, you can define it in IDL, and then you can use that the to JSON helper to render that as a JSON string.
All right. Thanks, Justin. I'm looking, I'm not seeing any others at the moment. So we've got a few more minutes till the top of the hour. So if anyone else has any other questions, we will wait just a minute, another minute or so, and hang out just in case. Justin, do you want to advance? I think there might be another slide that has some resources and other on-demand webinars in case people are looking for any other content that they might want to reference.
Right. So these are articles specific to the RtpsRelay and using OpenDDS on the internet. The next slides are kind of general OpenDDS resources. And I think there's maybe one more, which are even more general. Those are just websites for the project itself, source repo, again, our support and training and so on. And then our most recent release is 321. And you can read about it on GitHub.
Great, thank you so much. All right, well, if that is it for everyone and I'm not seeing any more questions, I think we can go ahead and wrap for today and give everybody a few minutes back before their next thing here at 11 o'clock. So thanks again for everyone for joining us, and we will see you next time. Thanks, Justin.